So this is our process for graphing sine and cosine using the transformation method. The nice thing about this method is all you have to know is what the parent function looks like, which we've shown in other videos. If we know the parent function of sine, the parent function of cosine, then we can apply horizontal and vertical transformations to it to get the graph of a more complicated version of sine and cosine. And our process for this is as follows. Solve b theta plus c is greater than or equal to 0 and less than or equal to 2 pi. We're solving that for theta, and the result I've already written over here. Now, you don't need to worry about memorizing this formula. It's just a matter of solving the inequality for the variable. I've written that out because we're going to reference those values in a moment. Once you solve that inequality, that handles all of your horizontal transformations. You don't need to know if there was a horizontal stretch or shrink. You don't need to know if there was a horizontal shift to the left or right. It's taken care of for you. This will reset the initial period of your function. So as we've shown in previous videos, how the graph of sine and cosine will be between 0 and 2 pi, what we find with this new inequality is that exact same graph will lie between those new values that you've solved in the inequality. At this point, you can then find p equals 2 pi over b. This will find the new distance of your period. The period of sine and cosine is typically 2 pi. But when you multiply a value of b to your variable inside the function, you are performing a horizontal stretch or shrink on it. So by dividing 2 pi by that value of b, you will find the new period. Once you find p, the next step is to take it and divide it by 4 and then add it to negative c over b, this value here on the left side of your inequality 4 times. That might seem a little odd. Why are we doing that? Remember when we graphed the parent functions of sine and cosine, we said the easiest values to work with were the quadrantal angles. By dividing your period by 4 and then adding it 4 times to this initial value of your inequality, you are finding the new 5 quadrantal angles that you can easily plug in. And when you do plug them in, you will get these 5 values for cosine and these 5 values for sine, just as we did when we were graphing the parent functions. There will be no need to solve any values. It's done for you in the process. At this point, all you have to worry about are the vertical transformations. So a vertical stretch or shrink and a vertical shift up or down. Once you list those off, you can then graph this table that you found and apply any vertical transformations to it. Again, the vertical stretch, vertical shrink, shift up and down, and if there are any vertical reflections. Applying those, you will then have the graph of one period of this more complicated version of your parent function.